Okay, now we're in Module 5, calculating the rotational inertia, and we will use these formulas, both the parallel axis formula and the inertial formula. We're going to do problem 37, which is calculate the rotational inertia of a meter stick with mass 0.56 kilograms about an axis perpendicular to the stick and located at the 20 centimeter mark. Treat the stick as a third rod. So let's draw us a meter stick. And we'll take a little section of this. We'll call it DM. And also up under here, we'll call it DX. And we know the meter stick is L length long. And we want to compute the inertia using this formula. So we need to find dm. So we can say dm over dx. It's going to equal to the same thing as the whole mass of this rod divided by L. So that would go to dm is equal to dx m divided by L. So we're going to plug this back into this formula here. And we're going to have I is going to equal integral, and let's just call R square L. Just make that L square. And for dm, we'll just put dl for the dx, dl m over L. Just to go to, we can take the constants out, which would be L M over L. And what we're left with is L squared dl. We'll take that derivative, M over L. When we do the derivative, we'll get L cubed over 3, and the limits will be from minus L over 2 to L over 2. That's the rod from one end to the other, with the center, from the center. And when we do this math, we stick this into this, we get L cubed over 8, that's 2 times 2 times 2, times 3. Then we're going to have a minus, which is going to make that plus, the same thing, L cubed over 8 times 3. And what we have here, from here we have I, center of mass, is going to equal m over 12 L squared. And we'll just compute this right now. We'll have 0.56 kilograms divided by 12 times 1.0 meter square, and that will equal 4.67 times 10 to the minus 3 kilograms dot meter square. Now the parallel axis theorem tells us that I must equal I center of mass plus H m is H squared m. So what is H? Let's just draw our little bar here. This is the center of mass, which is 0.50 meters. And here's where we're going to rotate at this 20.20 meter mark. So H is the difference between 0.50 meters minus where we're going to rotate this bar, change the axis. This is a rotational axis is 0.20 meters, which is going to equal 0.30 meters. We plug it into this formula, H squared m. We have H squared is 0.30 squared times the mass, 0.56 kilograms, and we get 0.054. And we're just going to add these two. This should have been to the second power. So I is going to equal to 4.67 times 10 to the minus 2 plus 0.054, which is going to equal 0.097 kilograms dot meter square, which is equal to 9.7 times 10 to the minus 2 kilograms dot meter square. That's the answer to that problem.